backward. This it means motion in one direction. So let's catch the definition together. It's motion in which the body moves forward and backward, but don't move up and down. I think you understand it well. What about to fly to these lovely examples? For the first one, train move, so train motion. Car also move, so it's car motion. What about bicycle? Bicycle motion. All of them, they are examples of the different types of the motion. Let's travel to this car. We have two cars. We know it has good motion. The first one move in a straight line, and second one also make you turn and move in the curve, and back again travel in a straight line. Do you think what happened? A straight and the curved line for the same time? Yes, they are the types of the motion. Let's catch it together now. For the first one, motion in a straight line. This is the simplest kind of the motion. As a car, as a train, different things. What about for the second and third? Motion curved line, motion in curved and straight line. At the car, when it makes you turn. So catch the type of the motion. Straight line, curved, a straight and the curved line. Let's travel for this. Now, for the motion, tell us about the speed. Do you think what is meant by the word speed? Speed is depending on, yes, distance and time. It's a distance moved by the body in 1 second. Distance and second, it means the time, both for the speed. Only, sure not, we have another definition. Catch it with me. Look at this. It's a distance moved by the body per unit of time. Both are right. Catch it. Distance, time, we catch speed. Do you think we can find it from where? D, T, and V. D, it means what? Distance. T, time. V, it means speed. Look, my dear, what happens if you want to catch time? You catch time back to the lost triangles. Look at this. Question mark for the time. So, time means D and V. What about D? D, it means T by V. Only, sure not, we catch the third one. V. V, it means distance over time. Wonderful. What about all triangle? D, T, and V. To catch any problem and you want to answer this problem, you be sure you have a distance, time, and speed. Wonderful and great that. Let's catch this example. Yes. Example 1. Body moves 100 meters in 2 seconds. Find the speed. Before answer this problem, you must be sure what you need. I need a time, I have a time, and I have a second. How can you answer it? Let's see the answer together. Get your given. My given, as you see, distance 100 meters, time 2 seconds. So this is only, sure not, I hear a lot of students catch the answer. Catch it, my dear. Number 1, write the law. V equal D over T. Only? No, we say V equal 100 over 2. I think that's enough. No, it's not enough. You must find the result. My result now, 50 meters per second. Take care, my dear. Law, and at the end, don't forget the unit. What is the unit now? Meter per second, because I work by meter and second. What about to fly for the other example? The other example, he tell me, car moves 600 meters in half minute. Calculate the speed. Good, my dear, but take care. We have here minute. Catch it with me. Let's see. Number 1, the given. What about the given? My given, it means what? Distance, or D, 600, time, half minute. Oh, I don't work by the minute. What I do now? Oh, a lot of students know 1 minute it means 60. What about half minute? Half minute here it means 30 seconds. It's great and wonderful. Catch the answer, my dear. Now the answer will be V equal D over T. You keep the law now and well. Catch the second one. 600 divided 30. Why we say 30? Because I changed the minute to second. Now the result will be good. 20 meters per second. Don't forget the law. Don't forget the unit. You catch a good answer. Now, all speed like each other? No, but the car, half minute, 30 seconds. Fly now, fly now, fly now. What we catch it? We have the factor that affecting for the speed. From the factors, I said it before, I have a distance, I have a time. So, let's catch the time. When the car moves slowly, this slowly, it means what? Slowly, it means it needs long time. What about if it moves faster? Move slowly, move faster, so the speed is changed. So the speed inversely proportional with the time, but at constant distance. It's great and easy to catch it. Now, this only factor? No, I have another one. It's a distance. When you move for long distance, the speed is very high. Move together. What about it move for short distance? The speed is low. So, speed is what? Speed is directly proportional with distance at constant time. It's great. Don't forget this crazy triangle. This triangle tell me what happened. Number one, we have a D, my distance. It's very important. Also, we have a speed. It's V. What about the third? Good. It's time. My unit. What is the unit? You say you have a distance, but by meter. You have a speed. Good. Meter per second. What about the time? Catch it, my dear. It's a second. So the time may be by second, can be by hour, can be by minute, but all time we work by second, my dear. Now let's see the other example. Look at this. Two cars. The first one moves 100 meters in 1 second, while the second moves 50 meters in 1 second. Ask yourself, which of the two cars is faster and why? To catch this, the car, you have 100 meters for the first car. What is the time? 1 second. 50 meters? Yes, in another 1 second. Directly when you find this, 100 for 1, 50 for 1. Which one is the faster now? Good, my lovely students, the first car is the faster than the second car. But I don't know why. No, you know it well. Catch this. Look, when I say why, you say because the first car cuts larger distance than the second car at the same time. And the speed is directly proportional with what? With the distance. All time. Look at the distance. Look at the time, you can catch your answer well. Good, my dear. What about the other example? Look, my dear. Two cars. The first move 100 meters in 1 second, while the second moves 100 meters in 3 seconds. By the same, which of the two cars is the faster and why? Get your given. 100 meters for 1 second. Another 100 meters for 3 seconds. What is the constant here? The constant here is distance. Catch the answer. Which one the faster? Fly, fly, and catch it. The first car, yes, is faster than the second car. Also, sure. Ask yourself why. This is back because the first car takes a shorter time than the second car, but at constant distance and the speed we know inversely proportional with the time. Directly with this distance, inversely with the time. Catch it, my lovely students. What about to fly to this? What types of the speed? We know the speed, it has different types. We know that. Let's catch the first, uniform speed. Non-uniform speed. What about the third? Yes, relative speed. So, the types, uniform, non-uniform, relative. Let's see how can we know the difference between all of them. The two runners move beside each other. This it means uniform speed. Suddenly, one of them moves fast and fast and fast, so it changing its what? It changes speed. So the first, regular speed. Regular, my students, it means uniform. So what about the distance? What about the time? Body moves equal distance in equal period of time. Both are equal. So we say uniform. Uniform speed, it has an example. This example, my crazy car back again. Did the car start to move? It's moved about 3 meters in 1 second. After a while, the crazy car move again, and the distance becomes, 3 meters in another 1 second. The distance is a constant and the time is a constant. It's okay, why not? What about if it moves again? When it moves again, the distance stays 3 and the time stays 1. Do you think why all of this? Distance equal, time equal. Catch it, my dear. It's a uniform speed. Why? In this example, body gets equal distance in equal time. Great. This it means uniform. Let's see this. Non-uniform speed or irregular speed. Irregular or non-uniform, I know you know it well. Tell me, different what? Different what? Look at this. Body moves an equal distance in equal period of time. Time is changed. Distance is changed. How can I know? Look at this example. My crazy car starts and move again, but now it moves 4 meters in 1 second. After a while, it moves again, and look at this. The distance is changed. What about the time? The time is not changed. It stays constant. Now, move again, my dear. Sure. When it moves again, you can find, yes, distance is changed, but the time is not. All distance is changed, but the time is a constant. What this mean? This means non-uniform. Look, in this example, the car with non-uniform speed because it moves in equal distance in equal period of time. Equal in unequal, this it means non-uniform. Wonderful and easy. But we have another important example. Look at this example. The car moves the distance here for 1. It moves again. The distance becomes 4, but the time is changed to 5. It moves again. What this mean? It means the 4 meters 3 seconds. The distance is not a change. What this mean, my dear? The time is a constant. The time is not constant, and the speed is a constant. Look at this. This car, it moves, yes, with non-uniform speed, equal distance and equal of time. So the uniform, it has 2 factors. For the first, equal distance and equal time, or the opposite, unequal distance for equal time. It's great and easy. Let's fly for the last one. Note. What's your note for this? Look. Regular speed is considered average speed. Regular, irregular, average. This means average speed, it means what? Go and back, go and back. It means total distance moved by the body dividing by the total time. Where is the law? The law is here. Average speed equal total distance, total time. Wonderful. But take care. V is not V. Say V dash. Why we say V dash? To be average speed. Total distance, total time. What about the other one? If the average speed equal uniform, do you think what happened? Speed. This means the motion of the body is uniform motion. Another one, it has a unit. Yes, we know the unit of the speed, meter per second or kilometer per hour. Both are right. Important to know meter per second for the small one, kilometer per hour for the biggest one. Take care, and this note is very important. My dear, let's see the important example. Take care. This example is very important because it has a lot of answers. Look at this. At the first, a runner covers a distance of 80 meters in a starting track in 40 seconds. Then he returns back and walking in 20 seconds. My dear, take care. When he starts, he moves 80 meters in starting track. Then he gets a time about what? 40. When he back again, it gets another 20 seconds. What do you want from this question? You can say, number one, find the racer's average speed. Number two, the average speed while returning. Number three, the racer's average speed during all trip. To catch this problem, get it as step by step. For the first one, the racer's average speed. When I ask me where is the answer, yes, it's my answer for the first, the racer's average speed. When it go, this is means what? He goes by about, yes, 80. Look at this, right below. Average speed, total distance, total time. 80 over 40 equal to meter per second. My dear, don't forget, V dash, it means average speed. 80, it means distance. 40, it means the time in second. Don't forget important thing. This is in one direction. Just he move forward. What about when he returning? This is, we'll see it now. V dash again. The racer's average speed while returning. He go 80. So directly when we say returning, also he returned by 80. The total distance over total time, this it means average speed. It means 80 over 20 equal 4. Do you think what this means? This it means total distance, total time for 4 meters per second. During return only. If you want to catch all trip, what you do for this? You can say the racer's average speed during all trip. When I say this word, don't forget to say I go 80 and return 80. So how many distance? I have the distance. I go by time and return in another time and 2 time. The same law. Total distance over total time equal 80 plus 80, go and back, 40 plus 20 for the time for forward and backward again, it will be 2.6. 2.6 what? Meter per second. Because we know the average speed, it has an important unit. What is the unit of all speed? Meter per second or kilometer per hour. But in this case, we work about the small unit, meter per second. It's great, my dear students, to hear that. Going 80, back 80, time 40, back 20, the total 2.6 meter per second. Look, relative speed. Relative speed, it means what? When you move and the car moves beside you suddenly, or the bus moves suddenly, do you think, what happened? your speed. In this time, it means relative speed. So, the speed of the moving object relative to the observer. Let's see. Yes, relative speed is speed of moving object relative to the observer, and catch it from the car. The crazy car start to move. It moves slowly now. Its speed, yes, 80 kilometers per hour. And suddenly the other car moved beside it. What is the speed for the other car? The other car, 90 kilometers per hour. Both of them move in the same direction. But the first one, 80 kilometers, and the second, 90. What happens if you stand in the ground beside the first car? You are beside it now. Then your speed becomes good. The speed of a slow car relative to an observer standing on the ground will be 80 kilometers per hour because you get the speed of the car. Now, let's see the other one. Yes, the speed of the faster car relative to observer standing on the ground will be 90. Do you think if you stand in the slow car, what your relative speed for all speed for two cars? Let's see. Yes, the speed of the fast car relative to the person sitting in the slow car, 90 minus 80 equal 10 kilometers per hour. Why we say minus? Because both of them move in the same direction. It's great and wonderful. Another one. Example. Car move. Yes, my crazy car moves by 80 kilometers per hour. In this other direction, there is another car moves by 90 kilometers per hour. Catch it, my dear. What about your speed if you stand in the ground for the first car? Yes, like last example, will be 80 kilometers per hour. What about the other example? You can say the crazy car moved by 80 kilometers per hour and the other car make a return and moved by 90 kilometers per hour. What happened for this? You can say, if I stand in the ground, sure, my speed for the car 90 kilometers per hour for the fast car. What about if I slow car and the other car move beside me? You can find that for the first 80, second 90, and I stay for the slow car. So my speed now, good, 90 plus 80, 170 kilometers per hour. Why we make addition? Because the two cars move in different direction, the opposite. Same direction minus, opposite direction, it means plus. Now fly to the homework. I'm sure a lot of students don't like the homework, but take care, my dear. The homework helps us to know how can you answer and understand the lesson. Question number 1. What is meant by average speed equal 100 meters per second? B. The body gets equal distance in equal period of time. Do you know how can you catch it? Yes, write the definition and write the number at the end. And for number B, take care to catch the definition for what? Catch it by yourself. What about the other one? Look, two cars. The first one gets 50 meters in 10 seconds. And the second gets 50 meters in 3 seconds. This problem, answer it, don't forget the law, don't forget the unit. Another example, ask which one is the faster and why. Car moves 250 meters in quarter minute. Find the speed of the car. Take care, you have a minute. Minute, it changes to second. 1 minute, 60 seconds. What about quarter? Catch it by yourself. Another one. The body moves by speed 50 meters per second. Find the distance if it gets 2 seconds. This is the time. It's very easy. Yes, another question. If the speed of car 200 meters per second, find the time taken if the distance taken by car 600 meters. The problem is very important. Be sure you have two things. You have a law. After that, after the result, catch your unit. Take care, my students. My dear students, I'm waiting you at YouTube channel www.facebook.com/science.thirdprep. Also, you can find this lesson on Face account science_thirdprep@yahoo.com. We arrived to the end. I hope you to understand the lesson. It's easy and wonderful lesson. I'm waiting you for next. Thank you and goodbye.